Cal O'Neill 151-69596. In this short video, I'm going to show you how to construct a roof geometry question, which asks many questions such as dihedral angles and developing different surfaces. So I took this question from this section here, which is found in David Anderson's book here. So as you can see, it says here the surfaces A and B have a pitch of 45 degrees, surface C has a pitch of 40, D has a pitch of 60. So look down at the question here. This is our A, B question here, and that's kind of our, we can draw out the outline, but we can't really draw out the kind of the rest of the inside parts here. So starting off here with our AutoCAD question, I've just drawn out here what we're given. So to start off with, the first step you can do is always just draw in what we're given already. So we're given the pitches of the roof, so that's at 45 degrees. You can see here, these are turned on at 45 degrees. Like so. This gives us the ridge of the roof. So you want the ridge of the roof. We can then look at different things. So we turn on our type A, and this is a step kind of before, let's go back now. So we have our ridge here. We don't have this line, we don't have this line, nor do we have this line. So to get this, we can then, because we've drawn this now, we have our heights. So we have this point to this point here is the height of our elevation. So you can simply just draw in a box around this basically. So we can then turn on our hidden lines, show the hidden detail. So as you can see, like I said, we can just draw complete blocks here. Now, when we project this line up, we can see here. Now, to get our roof, we know that the roof C, which is here, or D, sorry, has a pitch of 60. So if you draw a line 60 degrees, just up straight here, back to our box, we can then, that's the pitch of our roof here, found right there. That's one section I've found. Find here, we know that that point, or this line here, intersects, from just looking at the question, there's a line going across here. So if we project this line straight up, project this line up here, we know C has a pitch of 40. So if this was 40 degrees here, which it is, we simply just draw it up. That gives us a height. So this height here, it's on the surface B, which is this, sorry, the side of the roof. So you can just simply come up from this baseline up the height that we're given here and draw it straight across and project it back down. That gives us then our roof. Next thing we're asked to do, so we're asked to develop this bottom half section here of B. So all in here, around there. That's exactly what we're asked for. So to begin with, just turn on our trichy lines. So as you can see here, we're going to have a big step forward, but it's very, very basic. Like so, we've already given this here, so we can just, we already found where it's intersected in B. So if we were just asked to find the surface B, we're not including this or this, we could simply just rotate this down around, and we could just, that'd be a box in here, like so. But it's cutting through here. C is cutting there, so there's our surface C. So we rotate this point here, from here, rotate it down around, and that gives us a length here. So that's the true length of this line, but up in our elevation, it's just that little line there. So it's just that line there. So that's the true length of that line there. Next then we need the actual height of our overall roof. So we take the height from like that, this length here. So it's from swinging our compass like that around there, and that gives us that baseline there. We know then that the roof, because we did our 60 degrees, we could drop our line straight down. We then connect both the ends of the roofs into here, the edges. So then we can just keep this line coming straight down, because you know that it has to incline like that. So that's the true shape there. That's the true length, sorry. This is the true length of that. So as you can see, it's getting rotated in. Then once we have that, then we can turn on the actual developed surface. Like so. So as you can see, that's our developed surface. That rotated around will fit perfectly into here. Next on, then we're moving on to the front section of our roof. So this part here, this little triangle here is what I want to get out. So again, just turn on next one. So this line here. So as you can see, this is the edge of our roof. When we rotate that, this is getting our height, so we can drop it straight down. We know it stops here. It's our middle section here. When we rotate it, we can turn on our developed surface there. So as you can see, rotated around, we simply extended these lines out. Likewise, we just extended, brought these back to here where we know they end. We've done the exact same repeated process over here. That's our developed surface. Again, it's all about rotating from what we already know. So here we knew that we'd get our heights here, so that's rotating it here, and then we know our heights up here as well, so we can just rotate that there. Then moving on to the back section, of what we want to take out then is we want this surface here. So we want surface C developed. So when you develop surface C, again, it's the same kind of process. We are just taking out our developed lines again. So we know our heights. So this is our line 40, which is represented here. This section here is represented by there. So all we have to do is rotate again. We already know that where it is, so we just rotate it down, let us down, drop the point down here. We know the roof stops there, so that's how we get this stop point here. Likewise, we know that the roof stops. The line is connected up there. So as you see, it connects back to our main point there. So there, this is the outline of our roof, as you can see. So we are just looking to develop this surface here. So like I said, all we're doing is rotating what we already know, like we did up here. Rotate this point around, drop it down, then we know the roof stops there, so we can draw a line straight across, and we can stop here. So you have that in, you can just develop, just show you the true surface of it done. Like so. So you can see that there now. Again, it's just rotating what we already know. So we've rotated for a height there, okay, it's that point there. Doing the exact same thing here, we're rotating that point around till it's flat down here on the opposite side, so we get the true length of it. Bring it straight down then, like so. Lastly then, we're asked for the dihedral angle, so I'm going to try to find the dihedral angle between, I'll just turn off some of these points because they can be very confusing. So this. Okay, so we'll go with this. So trying to find the dihedral angle of this line here. Firstly, we draw off our dihedral lines. So like we said, we have to go look at a perpendicular. So as we look at a true perpendicular, we can get our true heights. Again, like in the previous one, we're trying to find the dihedral angle, we need to find 2 points. We need 3 points. So we have 1, 2, and then this is going to be our third one here. So we just pick a point randomly on then both surfaces. So we're trying to find the dihedral angle between this surface and this surface. So this is our line of intersection, obviously. That's 1 point on this surface, and then that's 1 point down here on this surface. And then project up again. Our true length. True length is found here, but the height is taken from there, which is equal. This is based. They're the same line there. This height, that height. So that distance is the same. They're both the same lines. That gives us our true length. Next thing we do then is look along these lines. Once we look along them, we can then project our dihedral angle out again. Like I showed in previous questions, we can always, if we want to, just use the rabattment method there, but I'll show you the long way around here using auxiliary methods. So again, we never extended these lines on, we just brought them up to the X and Y line, then we project these down. So like we've seen here, I've just projected these lines in here. This length, okay, like I said, this is X2, Y2, go back to our previous X1, X1, Y1 line, and we take the distance in there. So that line there is equal to this line here. Again, we're taking repeating this process again, so we know that this length here is equal to that point, that length there, and then the longer distance is equal to this length, and then just simply draw in our dihedral angles, connect up the dots, basically all of it. This is giving us an edge view. The second auxiliary is giving us an edge view. Gives our true length. So there you can see now we have an auxiliary angle found right in there. That's how you develop and complete a dihedral angle using the roof geometry method. Sorry, this is a completed roof geometry question using dihedral angle and developments.